We're now going to look at a bunch of examples where a constant rate of change of one variable with respect to another, in two cases time, allows us to model a situation with a linear function or a line. In this case, the slope of the line is going to be the constant rate of change. So our first example, water is pumped out of a tank at the rate of 10 gallons per minute, and the tank contains 500 gallons of water at the start of the process. And we're going to let y denote the amount of water in the tank at time t. Now, the value of y really depends on the value of t, so it varies as t varies, so this is a variable. And our first task is to find an equation showing the relationship between the variable y and the variable t. Now t is measured in minutes here, and we know that when t is 0, y equals 500 gallons. So we have a point on the graph already. We have y is the number of gallons of water in the tank at time t. And we'll mark off the y-axis in hundreds. And we have one point on our graph when t equals 0, y equals 500. Now what about, say, after 10 minutes? So our time is measured in minutes. How much water is in the tank? Well, the amount when t is 10, we have water is being pumped out at the rate of 10 gallons per minute. So 100 gallons, or 10 times t, have been pumped out. Now remember, y is the number of gallons in the tank at time t. So when t is 10, y is equal to the original amount, 500, minus 10 times 10, or minus the 100 gallons that have been pumped out. For any t, y is equal to 500 minus the amount pumped out after t minutes. Well, we know that the water is being pumped out at 10 gallons per minute. So after t minutes, 10 times t gallons have been pumped out. So y is equal to 500 minus 10 times t. And this is the relationship between y and t. We have another point on the graph here. From this, we have when t equals 10, y equals 400. And now, once we have 2 points on the line, we have the relationship between y and t is the equation of a line. So the graph of the relationship between y and t should follow this line. Now, it's not true that this relationship carries on for all t. Number one, t must be greater than 0, because we're talking about time, which must be positive. Number 2, after 50 minutes, all of the water is gone from the tank. The tank is empty. And the relationship stops there because 500 minus, say, 60 times t is 500 minus 600, so we don't get a negative amount of water in the tank. The amount of water in the tank is 0 from then on. So this particular relationship, y equals 500 minus 10t, holds up to 50 minutes, which is the amount of time that it takes to drain the tank. So this is true. Y equals 500 minus 10t. That's true for 0 less than or equal to t, which is less than or equal to 50. And we can graph this relationship. We have 2 points on the line here. We can join them, and this should cut the axis at 50. And now the portion of the graph which is relevant here are all points on this line between where t is between 0 and 50. So our graph looks like this, and it's exactly this part of the line which is in the first quadrant. How can I figure out how much will be in the tank after 11 minutes? Well, I have the amount in the tank, which is y, is 500 minus 10 times t. And this is, I'm thinking about when t is 11. So when t is 11, the amount in the tank is 500 minus 10 times 11, which is 500 minus 110, which is equal to 390, and our units are gallons.